In this video, we're going to be looking at the average gradient of a curve, right? The average gradient of a curve basically tells us how the curve is behaving between those 2 points. If the curve is stationary, if it's increasing, or if it's decreasing, right? The average gradient basically just is another way of approximating the gradient of a curve. Since so far we haven't learned calculus, we can't get the exact gradient at the point. So for now, we'll be doing the average gradient of the curves, which is just the normal formula of a gradient. They're just being fancy when they say the average gradient. So when you hear the word average gradient, what comes to your mind must just be normal gradient formula. Okay. So here we're going to do the average gradient of AC. So basically, it's small. Remember, gradient, it's small m, right? So you're going to have small m of AC, which is the same as YA minus YC, right? You can say YC minus YA. It does not matter which one you start with. All over. If you started with YA at the bottom, you must start with XA. That is what is most important. Whatever you start with at the top, you must start with at the bottom, and then XC, right? Now we're going to substitute. Y on A is 7. So I'm going to put 7, and then there's a minus. Y on C is -1. So we have -1 all over. X on A, we can see that is -3, and then we're minusing X on C, which is -1, right? And then let's see what this gives us. This is going to be 8 at the top. Then the bottom is going to be -2, which is -4. So if the average gradient is negative, it just tells you that the graph is going down, and of which is true here. You can see that the graph is actually decreasing between A and C. Right. Perfect. Now we're going to do the second example, right? Let's check the second example. So on the second example, they want us to determine the average gradient of the curve between x5 and x3, right? So in this case, they did not give us the points. But the exciting thing is they gave us the input so we can get our outputs, right? So firstly, we're going to take f of x and input 5 to get the y value when x is 5, right? And then we're also going to take f of x and input the second x value, which is 3, and get the y value. So firstly, I'm going to input 5. So everywhere I see x, I'm going to put 5, 5 and 5, right? So which becomes, let's see, what does this become? It's 5, then it's going to be 5 plus 3, which is 8, which is 40, right? So which means f at 5, it's 40, which means the point will be 5 coordinate 40. So the input is 5, and the output is 40. You see? Perfect. Now we're going to do f at 3. So wherever I see x, I'm going to put 3 now. Okay, so that I don't confuse you, let me just erase everything and start afresh. Sharp. So let's put 3. So we're going to have 3, 3, 3. So f at 3 is 3 plus 6, which is 18, right? So f at 3 is 18, right? Which means I'm going to have 3 as the input and my output is 18, right? Sharp. This I can call x1, y1, x2, y2. Then now I can get the average gradient, right? M average, in this case, is equals to y2 minus y1. Remember, y always at the top. If you started with y2, I must start with x2 at the bottom, then x1. Now let's substitute. Y2, it's 18 minus 40. all over. X2 is 3 minus 5. Right. And then here we can see that, okay, 18 minus 40 is negative 22. And then 3 minus 5 is negative 2. So the answer will be 11 when you divide them, right? And then you have calculated the average gradient. On B, they say hence. Remember, if they say hence in maths, they mean use the answer above. So we have m equals to 11. They mean use m equals to 11 and state what you can deduce about the function between x equals to 5 and x equals to 3. Remember I said, if m is positive, which means greater than 0, therefore, the curve is increasing. If the gradient is positive, it means the graph is increasing. Right? Then that's what you can deduce, basically, in this case. And that's it, ladies and gents. I'm sure you are realizing that the concept of average gradient is just not the normal gradient, right? I hope this makes sense, and don't forget to share and hit the like button, subscription button. If you have some things that you feel like I should be adding and all that, please leave a comment. Yeah, we family, we have to work together. And yeah, I'll see you in the next session of Maths Fanatics 24/7. Tango, aluta continua.